Hello guys, today we are going to learn about test benches. Test benches are an important part of your circuit design. It's where you use your PC to validate the model that you write in Verilog or VHDL is right. Okay? As usual, we are going to see some labs after we learn the basic theory, and I hope you guys enjoy it. Okay guys, so what are test benches is all about? It's all about simulate on the PC before you implement your circuit in the FPGA. Okay? It's going to allow you to debug line by line your model. This is quite helpful because it's also help you to understand what your code is doing. Okay? It allows you to use external files to simulate your circuit. Okay? You can have a text file with all the inputs that need to be created, that need to be tested, all the use cases of your circuit, and you need to validate if this is going right or not. Okay? So here is just a small diagram on what a test bench is. It's actually another Verilog model that is going to instantiate the circuit that you want to test, which is called the device under test. Okay? When you are creating test benches, you have a bigger subset of Verilog available. I mean, now you can use delays, you can read from files, you can display messages, and all these sort of things that you normally have in a normal language. Okay? Guys, before we start our lab, we're going to learn some new concepts. Okay? The first one is to learn how to instantiate a circuit. As I said before, the first thing is that we need to do in our test bench is to instantiate the circuit that we're going to test. Okay? In order to instantiate a circuit, we use the module name of the circuit, okay? This symbol here to indicate that you're going to put parameters as well. This, by the way, this is optional. Your circuit may or may not have parameters. The instance name, this is just the name that you're going to give to your circuit after it is instantiated. So it can be anything like U0, ABC, anything at all. And here is where you connect the ports of your module with some wires or rags inside of your test bench, okay, or your other circuit that you are creating. As I said also, when you create test benches, you have a bigger subset of the Verilog language. Okay, one of them are the display, which is kind of the printf of Verilog. Here you can add a message that you want. The stop, that is going to stop the simulation, the finish, that is going to finish the simulation, the error, that is going to create a message and also point out that the test bench have an error, okay? The delay instruction, which means after some delay, he's going to execute some action. This is actually really interesting and it's really mandatory to have a delay after you set up the ports, because you need to give this delay to make the simulator fetch the output of your circuit, okay? And the initial block. The initial block is just some block of code that is going to execute once at time equals 0, okay? We also have for loops, we can read from files, and some more stuff that we're going to learn as we progress in our learning about how to create test benches, okay? We're going to switch now to the lab, and hope you guys enjoy it, guys. So this is the lab 4. This lab will be about creating a test bench for our previous circuit, the ALU, okay? And here is just a quick to-do list on what to do when you're going to create a test bench for combinational circuits, okay? First thing that we need to do, declare rag and wires that are going to be connected to the input and output of your circuit, okay? As a rule of thumb, we use wires for the circuit outputs and rags for the circuit inputs, okay? Then we instantiate the circuit that we want to test, and we simulate by using the initial block, okay? So again, this is the set of rules for combinational test benches, and we're going to switch now to the screens. See you soon. Okay guys, in Vivado we just opened our last project, the ALU. Okay, and well, just to remember out, the ALU is just a circuit that is going to be used to create to solve arithmetic problems. For instance, to sum, to subtract, to multiply, to do AND or and SHOR operations, and so on. So we're going to start now just by creating a new module, in the simulation sources, and this model is going to be the test bench that is going to instantiate our ALU circuit and is going to simulate the ALU and verify the results. Okay, and this is what we are just doing now. And well, after you create the project, after you create the file, a wizard will pop up, and you just delete the inputs that he tried to add. And now we open the file and we delete these comments, and we add what you want to do. Okay, the test bench, there is no port, so we can delete them. And the first thing is to use regs for inputs and wires for outputs to map some variables to our circuit. Okay, rule of thumb: use reg for the circuit inputs and wire for the circuit outputs. Okay. Now, the second part, we instantiate our ALU circuit. Okay, the syntax is quite easy. It's just the module name, the sharp character followed by the parameters if needed, followed by a name that is going to be your instance name, and the port map. Now, after our circuit is instantiated, we're going to create an initial block that is going to be executed in the beginning of the simulation at t equals 0, and it's on the initial block that we're going to add the stimulus to check our circuit. Okay? One point to remember is that on every input stimulus that you add, you need to do a delay to fetch the output. Okay? To add a delay, you use the sharp character followed by a number, which is the amount of delay in time units. And after this time pass, you can safely read the output and see what the simulation returned. Okay, here we just put A and B to a certain number. We are selecting the sum operation, and we're going to add a delay and see what is the output. A nice command that we are going to use right away is the $display, which can be considered as the Verilog printf. The syntax is quite the same as the printf, but the syntax in the beginning changes. Instead of printf, is display. So here we just print out the value that is going to be returned after some time. And when you run the simulation, we're going to see that this result will be printed out. Another important point in the test bench is to verify if the output is true. So here we just put an if, so just to verify if the C is really equal to A plus B, and if not, we throw an error. Is the $error command, and again the syntax is a little bit like the printf, and if some error occur during this your simulation, you're going to see an error. Okay, now we just put the simulation to run, and after this we're going to see the time diagram of everything that happens in the simulation. We're just selecting some signals and we're changing the data type to unsigned, just because we put the information as unsigned, so it's easier to see what is going on. Okay, perfect. The result operation is there. And well, this we just had a simple case, okay? Normally a circuit has a lot of test cases to validate if the circuit is going right or not. Okay, when you do test benches, you gain the ability to debug your program. So now you can do step in, step out, step over, as you normally do when you debug a program. Okay, this is quite useful because sometimes you want to understand a little bit more about Verilog. You want to understand if your always block is executing as expected. So it's an important feature to have. Now, as I said, we really need to test all the operation to validate if the circuit is running. So we just copy and paste, and we're going to change the inputs and change the selected operation to exercise other ALU operations like subtraction, multiplication, and so on. At this Okay, now we can see that we're going to have two operations, uh, add and subtract. I'm just changing now the signals just to put it more clear for you guys to understand. It's quite boring, by the way, to convert to binary by head all the time, and this is a quite nice feature. Okay, now what we test? Add and subtract. Okay guys, now instead of copy and paste for all the possible operations that we have in our ALU, we're going to change a little bit stuff. We're going to do a for loop that is going to go from 0 to the maximum number of operations that we have in our ALU. By the way, I'm just showing how to create an integer variable in our code. And this will exercise all the operations with just one for loop, which is quite cool because I mean it's going to be easier to understand and shorter to read as well, the test bench. Okay, I'm just deleting out the previous test and we are going to do a for loop. And by the way, never forget that the delay that you need to fetch the simulation output need to be done inside the for loop. And that's it. Now if we open up all the results, we can see that we exercise all our ALU circuit, okay? So let's call the day off. And next video we're going to learn now about sequential circuits. Circuits that use a clock, which can memorize stuff. And see you soon in the next video, okay? Ciao, ciao guys.